All right, I think we're back. What was I saying? So I think I was saying if I change something here, this should be quicker to build. So that was pretty quick. So that's what I used to do. And then, yeah, so the more you see this, like if you do this for work, you'll be able to just write stuff and not compile it for like a couple of minutes and then. All right, so yeah, very nice. This is a really neat way to work with UI, in my opinion, for a native device. I mean, web is always a couple of decades ahead, but for native app writing, this is a pretty neat way to write apps. Okay, cool. So we already have Hello World. We don't need the image, so let's remove that. So we could now type the UI component's name and just write it by typing. It's really good. The code completion is really good. So I could start typing button, and it gives me the thing that I want to do. But let's maybe pretend we don't even know the name of the component. We can do the same thing that we've done in Interface Builder, where we go to the plus button up here, and we have a button. So we can now drag the button in the code if we want, or we can drag it, I believe we can drag it here. Can we not drag it there? I'll just drag it here. And we have a button. Very nice. Button should update there in a second. Oh, preview paused. Let's unpause that. And I think we said toggle. Very good. Okay. So what are some of the differences that we're seeing here? So here we're dragging things wherever we want, but as you saw, that came with some caveats. It doesn't build nicely with other devices, so we'll have to do some cleanup work here and make the layout nice. Here we drag things on, and then they kind of clump in the center for now. So it is already designed in a way to work that it works with all screen sizes. One thing, if we wanted to mimic what we have here as close as possible, where it's kind of upshifted to the top and not centered here, one thing we can do is we have, so this is called a V-stack, a vertical stack. So a V-stack contains other views. So we have a button and a text. So if we want the V-stack to show things at the top, we can just say spacer at the bottom here, and it'll move everything to the top. So the spacer will take up whatever space it can. If we add a spacer at the top, it'll kind of just mimic what we just did. And if we put another one here, it'll divide it evenly between those two components. So yeah, VStack, a collection of vertically stacked views. There's also an H stack and a Z stack that we'll see later. But yeah, very nice. Okay, so how do we toggle the visibility of the button? Of the text field. So we'll talk about all of the peculiar curly brackets here much later. Right now, I don't see a way. So we don't have an outlet to this text field. We don't have really any way to interact with this. So how do we interact with this text field? And this is this is a very simple illustration of one of the main differences between SwiftUI and UIKit. And so there's more to it, but this is, I think, a first way to show how significantly different the two are. So UIKit is imperative programming, uses imperative programming. And let me bring back my iPad real quick. Quick time. Okay, and the transport created some. Okay, so UIKit. So the programming paradigm it uses, and does everyone know what a paradigm is? What's a paradigm? It's like a
Like a model or worldview.
Worldview, yes.
Yeah.
I think that's a good analogy. Yeah. So the way that you approach everything. So worldview is great. So Swift UIKit uses imperative programming. Who has heard this before, this term? Okay, very good. Not expected that you would have heard this. What is imperative programming? Imperative programming is you describe all of the actions that should happen. So if I'm clicking this button, I'm accessing this label. I'm telling it, hey, you have this is hidden thing. I'm telling you, so set this to the opposite of what it was, and then the label now knows what to do, but maybe in another UI framework, maybe you would say label.update. So I'm telling the label what to do. So the button is pressed, there's an action there, and now step by step I'm describing the actions that should be happening. Swift UI uses something called declarative programming. And we'll talk about why this would be happening a little bit later. So declarative programming, you declare what should be the truth. You just state this is what should be the state of this thing. So if I say and maybe the best way to demonstrate this is to just implement this here real quick. So if I have a variable that says label is hidden, and maybe we would start off with false. So if I, so I'm just taking this as the truth. I'm saying the label is hidden. Now the view should render as if this was the truth. So let's add some logic here to the text field. So if label is hidden, so I guess if label is not hidden, I guess maybe I could have picked label is showing, maybe a little bit simpler. So if the label is not hidden, yeah, let's just do that. Is showing label, just to keep things a little bit simpler here. So if is showing label, then our text field should be showing. So this is the code that generates our view. If the label is, if this variable is set to true, we are showing this text. So I'm not saying, hey, label, I'm setting this property on you, and then, oh, label update, so that you can hide yourself. I'm declaring this is what the view should be, and this is what the view will be. So let's. I guess we're seeing what's going on here. I guess this should be true for now. Okay. So if the label should be showing, we're showing the label. And now, so if you're saying this is, and the canvas updated here, if we set this to false, the label hides. So we're declaring what should happen, and it just happens. We're not describing how it should how this behavior should be happening. We're not saying, hey, label, you have this property, set yourself to hidden. Hey, label, update yourself. We're not telling the label what to do. We're just describing the overall outcome that we want. Does that make sense? This to you. So if you're 100. So who has any questions here so far? Yeah. Yes.
I'm just a little bit confused.
Good. So this should sound really weird. You should. So if you're actually understanding what I'm saying and you have not seen this before, you should scream at me and throw something at me. It makes no sense. So how is this supposed to happen? So that's an appropriate question. So if you don't have this question, so maybe you're not quite understanding the implication of what we're saying here. I'm assuming most of your schooling so far has used imperative programming. So you're describing the things that should be happening. It is the rage right now, especially in UI frameworks, to use declarative programming. And that is, you just state the truth and it shall be. It happens. We will unpack all of this. You might feel really uncomfortable right now. We will unpack it all. And I would say, so if you're really used to imperative programming, you've done this for years, this will take a couple of weeks to really feel comfortable. You're always going to be wanting to set a property on this view component. And that's normal. I went through that. It was horrible. Once you're accepting that this is how it works, it's very nice. We'll talk about the benefits of this probably next week, but so there are some really nice benefits with it. There's some drawbacks, but there's some really nice benefits with it. All right, so given this, so we kind of cheated here. So we set this to true and false in code. We obviously want to toggle this with a button. Let's see what happens if we try to do this. So where would we put this code if we're updating this variable here? So where would be a good place to put this? No, I mean, like, where would we put? If we're trying to update this variable here. So who has a inside the button here? Yeah. So this seems like a thing that could execute. We have some curly brackets. So let's write some code here and hope that the button will update our variable. Spoiler, it will not, but we're on our way, yes?
Didn't you say that before we do make changes like this, we should be committing?
Not for SwiftUI. So SwiftUI will not break on you in weird ways. So this is
just for storyboards.
This is storyboards, yeah.
Oh.
Yeah. But yes, good point. So let's try. We're on the right track. So is this the right place to put it? But we still need to do another thing. So is showing label. Let's update that to not is showing label. So we're just negating the thing and assigning it to this variable. And Xcode is yelling at us. So there's some red. This red is different from the red that we've seen in storyboards. How is this red different? So when we did something here, we broke something. I was able to build the app, and then when I pressed the button, the app crashed. How is this different? It won't let me build it. Yes. So if I hit run here, it will not let me. So build failed. So this is a compile time error. What we had in UIKit was a runtime error. So runtime errors, other word for that is crash. So everyone has heard the word crash before. Who's heard the word compile time error before? Yeah, great. So if you were to write an app, what would you prefer, compile time errors or runtime errors, if your goal is to ship functioning apps that are not annoying users? What do you, as a programmer, what are you likely to prefer, runtime errors or compile time errors? Compile time errors. Why?
Because if there's a bug in runtime errors, it would show up in the original app, and
yes.
That would create a problem.
Very good. So I can't ship this. I can't build this. I can't even send this to a user because the compiler is telling me, hey, you're doing something wrong. So compile time errors are our friend. Whenever we can have the compiler help us find bugs, that's perfect. So we did something wrong. We're on the right track. How do we fix this? I'm going to just fix it for now. We'll talk about what this means in a second here. So this error message cannot assign to property self. Cannot assign to property self is immutable is not helpful to us. We have no way to approach this error message at the moment. Yeah, question?
Oh no, I was just saying, like, do we have to set it to let so that it's like
We can try. So let's try that. Let's try to build it. So the compile time error message changed. So it's telling us now that let, so it's a constant. We're trying to update a constant. Very good. So constants we can create with let. We should be creating constants whenever we can. But here we need a variable. So we want to be able to update this, but we're not allowed to, and we'll talk about why not later. So let's just fix this. I'm going to add an annotation here. I'm going to say state, and I just added it above it. So you might sometimes see it in front of it. It's the same. Kind of. So they're different. They're doing very different things. But so I prefer these things to be above the variable. I find it just a little bit more legible. So. The compile time error went away. We'll talk about what this means in a second here. And so let's see if we can build it. OK, so hello world is showing. When I press the button to toggle, I'm stating a new truth. So the truth before this was the label is showing. When I'm pressing the button, the truth or the state of this view will change. It'll now state that the label is not showing. And again, I think you're understanding, like there's some magic here. I'm not saying label, please hide yourself. I'm just saying, hey, this is now the new truth here. So let's see what happens. Let's hit toggle, and the label disappears. And yeah, so again, this should look like magic to you right now. So we'll go over why this is happening. We'll unpack a little bit more. Yeah. So I guess we'll unpack some more things today. We won't unpack all of it today. But yeah, any questions before we keep going here? So very different approaches. Imperative programming for SwiftUI, we describe how something should happen. UIKit. We describe how something should happen. SwiftUI, declarative programming, we describe the end result that we want, and then it'll just update magically to the thing that we describe, even if we make updates. So those are pretty fundamental differences in approaching the problem of creating this UI. So yeah, any questions here so far? Okay, so then we'll talk about what the state thing means, all of that next week. Let's unpack the error that we got here. And I think that's the only thing that we'll have time for today. So cannot assign to property, self is immutable. So let's make sense of this error. What does this mean? So self being immutable, what we're really doing here, so there's some syntax that was left that we're able to leave out that we can add now. So self dot is showing label is what we're really doing here. And the other thing that we're doing here is self dot is showing label. So we're reading from self dot is showing label, and we're assigning to self dot is showing label. So we have already figured out that so our is showing label property we can't change it. It is so the opposite of immutable is mutable. So is showing label is a variable, so it should be mutable. We should be able to change it. The thing that is not changeable is the self. So self is immutable. So we can't change self. So what is self? It is our content view. So our content view, one thing different about it, if we go back to UIKit, the view controller here was a class. Content view, the view here is a struct. So structs in Swift, and I'll go back to the QuickTime player here. So structs in Swift are value types. classes are reference types. And we'll unpack what this means. So a value type is a thing that if you can recreate the exact same thing, all of those are to be treated the same. Who can think of something else that behaves like that? So even if you haven't heard the word value type, who can think of, so if we have two of the same objects, they're the same. Like who can think of something that we use all the time when we're programming? So we wouldn't think of that we're like changing the object. We're just treating all of the objects like it the same. Any ideas? It's also totally fine if not. So how about integers? So if we have an integer 7, so any 7, they're indistinguishable to us, right? And I'm not expecting that if I'm passing 7 into a function, and I wouldn't expect that I can change something about 7 that now 7 becomes 8. So if I want a variable to be 8, I assign a new value type to it. I assign a new integer to it. So integers are value types, doubles, floats are value types, booleans are value types. So they are kind of like $1. So if I give you $1, it doesn't matter if which dollar I give you. It's $1, and I wouldn't expect. I wouldn't expect that if I give you $1 that you could change something about it, and now it turns into $100. So I can't change something about the thing that I gave you that will change what it is. So dollars are dollars. It doesn't matter which dollar I give you, it'll always be the same thing, and we're treating them equally. We're treating them as if they're the same. So this is a little bit different. If I give you my car, and your dog has an accident in this car, that doesn't mean that. So first of all, so now So first of all, there's now a specific car that has a dog accident in it, and if you gave me another car for this car, even if it's the same car, it might have a different VIN number. I might have some trouble with this trade that you made. And also, so if I give you my car, your dog has an accident in it, and you then give me back that car. So I gave you the car, and it came back changed. So does that make sense? So dollars, kind of the same. You can treat them all the same. Cars, whatever you do in them matters to me later. So same thing with structs and classes. So view controller, this is a reference type. So if I'm giving you a reference to my view controller, I have some opinions about what you do to my view controller. In a programming sense, the main thing I will be having an opinion about is if this is on a different thread, we might have a race condition. So all of those things don't matter when we're dealing with value types. So value types, they're different things. So each thing is treated the same, but I'm not expecting that you can manipulate the thing that I give you. Does that make sense? Kind of, yeah? Okay, good. So the error that we have here is content view is value type. So maybe for this exercise, think whenever I'm saying struct or value type, think something that's you easily think of as a value type, so an integer. So let's say we had the integer 7. If there was some functionality on the integer 7, I wouldn't expect you to be able to do something with my 7 integer so that 7 turns into anything other than 7. So that is the kind of fundamental thing about the value type here. So I shouldn't be able to change something about the value type inside the value type. So that's meant here with self is immutable. So we have a struct, and we have to kind of live with what we have. So we can't change it. So it's immutable. Any questions here? Yes.
Side tangent. Is that then what state does? It makes it mutable and also makes it so that you can change it. It's like an attribute, kind of like 7 is like, hey, I have a toggleable thing that says, hey, what color 7 I am.
So very good question. I like what you're going there. Where you're going there. So 7 still doesn't become mutable. So we are carving out a little spot inside 7 that becomes mutable.
Oh, okay.
So maybe another analogy we can use here is, so if I have a box, I have an intricately carved box, so I can give you this box, and hopefully your dog doesn't do anything to it, and then you can give it back to me. So you won't be able to change anything about the physical nature of this box. But the box has this spot inside that you can put something in. This is kind of what's happening here, where we have, so you can mutate the inside of the box, but you can't easily mutate the box itself. So changing the color of the box, you won't be able to easily do, but you can easily change the inside, what you put in the inside of the box. So in this box analogy, the inside of the box, so the contents of the box would be a reference type. So we have a reference type where we can, who remembers what a reference type is? So a reference type, we're dealing with memory location. We'll go over all of this later. So yeah, we have a reference type inside a value type, and that's how we can mutate state there. We'll go over this again. I'm just mostly showing, I'm trying to showcase the differences here, and yeah, we will go over it again. So the state annotation, we're carving out a little space inside here to be able to put something in there that we can change. But yeah, so if you're thinking about it, so we're trying to change a property on our view here, and it's telling us that the view is immutable. Again, this should raise some alarm bells. If I have a view, I want to be able to change things about it. So it seems like a really strange concept that views are immutable. And so for the rest of the lecture, we'll kind of unpack one benefit of this, and we'll go more into depth next lecture as well. So we only have 10 minutes. So I want to do like a little visual, like a little visceral demonstration of the benefits of having immutable views. So views that do not change, and the strange thing that we'll do to allow our views to update, even though our views are immutable. So we only have 10 minutes. So let's say we're gonna build a house, and our house we're gonna have three properties on a house. So roof type, and so maybe there's a gabled roof, there's a flat roof, and then I think these are called shed roofs. So a flat roof that is at an angle, and then so we have maybe since we don't have a lot of time, we'll just do two. Window count. Window count, and it'll just be a number. So we're building a roof. We're building a house. These are the attributes of the house that we have, and as we're building the roof, maybe things change. Maybe I'm the contractor, and so I already built the foundation. I started building. I have the foundation. So the person who's paying me to build this house, so maybe the owner could come at this point and say, I know you've started already, but so maybe we started with 4 windows and a gabled roof. So I've already started, and so the owner could come and say, hey, actually, scratch this. Let's do 5 windows. Fine, I can do that. So yeah, that's kind of how we are thinking about building a house should work, right? So nothing is really set in stone until it's set in stone, until it is built. So if I'm already building the roof, maybe this would be a little bit more work. Maybe I'd have to like demolish a wall to add another window. But that's kind of how the real world works. So we have a thing, we are kind of incrementally building it, and we have some properties on it that we want to reflect. We want to be reflected. So let's do a little demonstration. So there's another board there. Who wants to be my helper here? So it won't be a lot of work. Any volunteer real quick? I need a helper, really short. Perfect, yeah. So if you could, if you pick a color there, and so you're gonna, so if you go to that board there, as a group now, we're gonna decide what our house should look like. So what kind of roof do you guys like?
Flat roof.
Flat, okay. So can you just draw like a straight line for, oh yeah. Oh, perfect, gabled roof, yeah. We all decided on a gabled roof. Perfect, it's fine, it's fine. Okay, how many windows should we build? 7. All right, 7. 7 windows, can you write 7? All right, so I am now, so I'm gonna be pretending to be, so what we did just now is more real world, how we interact with things. Now we're gonna build a house like a computer builds it. So, or like an iPhone app works. So to set it up, we are in a multi-threaded environment. So we have a UI thread that does all the UI stuff. And so you can, I'm not gonna ask you for a while to do anything. So yeah, we have a UI thread, and then we have some background threads maybe. So maybe we're fetching something from the internet, maybe we're doing something really expensive computational wise. So we have multiple threads, multiple things that can happen at the same time. So that's the stage that we're in. We're now trying to build this app. We're trying to build this house. So the user selected this house to be built. Okay, so I'm looking at that. As I'm drawing this house now, I want you guys to just change that. So you can just change it to something else. So I'm going to look at this. So I see gabled roof 7. So now I'm going to draw a house.
20 windows. Which is the 20.
Okay, so I'm gonna draw 7 windows. Yeah, I'll do it this way. All right. Okay. So this doesn't match anymore. So I had gotten instructions. I started doing my thing, and in the meantime, something happened. Something updated. So that's the bane of multi-threaded programming. So you have things that you read something, you do the thing, and something else updates it. So that's how house building works on a computer. So we're not necessarily agreeing with the things that we agreed on and that we built, because something might have updated it. So this is what UIKit does. So UIKit, we could run into this situation. There's tools around this, but they're fairly complicated. We read a property, we do the thing, we read a property, we do the thing. So now let's do it in the declarative way. Can you reduce the number of windows again?
I'll do 2.
Okay, so now what I want you to do is, so I'm looking at this. You're gonna change something, but then someone in the room is gonna say, "Hey, stop!" And then we're gonna update what we're doing here. So I'm gabled roof 2 windows. So I'm gonna start drawing. And then so someone yell, "Stop!" while I'm not finished. Okay, good. So has it updated? Just update it real quick.
4 windows.
4 windows. Yeah, there you go. So someone yelled stop. Perfect. Okay, so someone yelled stop. I'm not finished yet. I'm pretty much almost done. Oh, count of windows has changed. So this is what SwiftUI does. we tear down the house and we start from scratch. So gable and 4 windows. Okay, so I'll just do it this way. Okay, so the nice thing about immutable views is, and we have 3 minutes, good. The like state thing that we have here is the thing that yelled stop, something updated. So there's some magic there that we'll unpack. So if a property updates in an immutable view here, we tear everything down and we create the thing that we stated that we wanted to build. So very inefficient in the real world. So you can sit down. Sorry, thank you so much. So yeah, very inefficient in the real world. We don't want to be tearing down our house when a little property updates. But as you can tell, the problem that we had run into, that we didn't agree on the thing that we wanted to build and the outcome that we had, that went away. So there's a cost here. We are starting from scratch if something updates. But the outcome is we actually have the thing that we want. And since computers are so fast now, our phone is so fast, the like additional penalty of having to start from scratch is negligible. The benefit of not having this problem is huge. So this is the nice thing about the declarative programming style, where we're just describing the thing that we want, and we never end up in a weird state where as we're starting to draw something, something updates. Yeah.
What if you have something that's like real time, saying like maybe I have like a camera feed going on, and it's like maybe something that's always changing.
Yeah, so I mean, like this works really well with UI stuff. I'm not sure. So so yeah, what would that be? Yeah, I'm not sure. I'm not sure how to answer it.
All right.
I'll think about it. Yeah, so we have 1 minute. I'll think about that for a second. In a second. Any other questions? Okay, cool. So so yeah, maybe just to wrap up, or like to restate a couple of things. So declarative programming is weird. There's some like really weird things that are not intuitive, or like seem really wasteful. The benefit of it is thread safety. So we live in a multi-threaded environment here. This solves it. So like there's no way that we can end up in weird states. So that's really nice about this. And then yeah, so there's lots of things that appear magic now, right now still. So how does it do this? Maybe there's still some reluctance in accepting that I want my views to be able to have properties that can change, that are not like magical like this. So we'll unwrap all of that. But yeah. Anyways, yeah, officially lecture's over. I'll see you guys next week. And so, okay, camera feed. So